Bismillahirrahmanirrahim. We have seen that the linearization for this dynamical system dx by dt to be equal to f of x tells us that if the derivative of f at x star equilibrium point is greater than 0, then x star is a source. If f prime at x star is less than 0, then x star is a sink. But if f prime at x star is equal to 0, we can't conclude anything. We can have any behavior. So we will be looking at some examples where f prime at x star is 0 and the point equilibrium can be stable, can be unstable, or can be half stable. For that, let's consider first very simplest example, that is dx by dt to be equal to minus x cube. We can plot this. You know that this is x prime and this is x, and the plot looks like this, something like that. Forget about my crazy drawing. So it's when x is less than 0, x prime is positive, so flow should be rightward, and then for x greater than 0, the x prime is negative, so flow should be leftward. In other words, the point equilibrium point, which is x cube equal to 0, is x equal to 0, is this one, is stable, is sink, and hence stable. Now we are taking another example. Now consider this guy over here, dx by dt to be equal to just x cube. Now we can plot this. You can solve and see that x equal to 0 is its equilibrium point. So you know that the solution looks like this. The graph looks like this. X prime x. The graph looks like this. When x is less than 0, x prime is negative, so it should be leftward. And for this, it should be rightward flow. So the point x equal to 0 is equilibrium point, and we can see that this point is source because it is repelled from both sides. The flow is repelled away from both sides, so this is source and also unstable. You know, you can't conclude this from this derivative test because f of x is 3x squared, and if you put this 0, it is 0, so we can't conclude. But from this graphical behavior we see that it is unstable, and previously when there was minus, it was, so it is unstable. Previously it was stable. Now we can see another example, in fact very interesting example. Let's say that is dx by dt to be equal to x square. It's not hard to show that x equal to 0 is its equilibrium point, and if you find its derivative, it is 2x, and f prime at 0 is 0, so we can't conclude. But we can go towards graphical way. Then we know that the graph of this on x prime plane looks like a parabola, so it's positive from both sides, so it is directed towards right always. And we can see that the point, this x equal to 0, which is equilibrium point, is stable from this side but unstable from the other side, this side. So it is, we can say that, half stable. So from this discussion we we see that if f prime at x is 0, x star is 0, then we can have stable equilibrium point. It can be unstable or it can be half stable. So we can't decide, exactly what is going on unless we see the behavior graphically.